Welcome to solverfy.
Okay, in this question, we have to find out the probability density that a measurement of the energy would still return to the value that is h cut omega out of 2, or it is getting to h cut omega. So initially the particle is at the ground state, so in the initial wave function is given as, so the initial wave function, which is x naught psi into x and 0 equal to psi naught, and this psi naught correspond to the, and this is correspond to v equal to half m omega square x square. This is the potential, and we know that the psi naught x equal to m omega out of pi h cat 1 out of 4 e raised to the power minus m omega 2 h cat x square. So when omega change to 2 omega, then the potential change. So the wave function keeps on evolving under the new potential, and this new potential is given as a psi x t equal to is sorry is evolving under the new potential, which is v is equal to 1 out of 2 m 2 omega square x square. So therefore this potential v is equal to 2m omega square x square. So under this new potential, we have to find out the probability to get the value h cut out of 2 and h cut omega. So we know that the energy value for the n stationary state is given as n plus 1 out of 2 h cut omega. In this case, we have given the omega is equal to 2 omega. So we put in above equation, so we get En equal to n plus 1 out of 2 into h cut into 2 omega. So therefore this equation, the value of the ground state energy is equal to 2n plus 1 h cut omega. So here n is equal to 0, 1, 2, 3 dash dash dash. So putting, so it means that the possible energy state are, so the possible energy state are h cut omega, 3 h cut omega, 5 h cut omega, dash 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 dash. So from the result we see that it is impossible to get the probability of h cut omega by 2. So it is not possible. It is not possible. So therefore the probability of the energy equal to h cut omega of 2 is equal to 0. And now we have to find out whether the probability is equal to h cut out of omega. So now we can write the wave function, which is psi x into t is equal to summation y from 1 to infinity cn, which is some constant, into the wave function of the n stationary state, and e raised to the power et out of h cat. So for the probability of the energy at n energy state is equal to Cn square, which is has been derived. So therefore the probability of energy equal to h cut omega is equal to the probability of the energy at the ground state. So therefore we can write this probability equal to h cut omega is equal to modulus of c naught square. So now we have to find out this c naught square. So we use the wave function, initial wave function, which is psi x to 0 is equal to m omega out of pi h cut into 1 out of 4 e raised to the power minus iota, minus m omega out of 2 h cut x square, and the wave function psi x into 0 is equal to summation I from n from 0 to infinity Cn and psi n. So multiplying by psi naught, we get this equation as psi naught into psi into x is equal to summation n is equal to 0 to infinity Cn psi n and psi naught. So therefore this psi naught is equal to minus infinity to infinity m omega out of n h cut to 1 out of 4 e raised to the power minus m omega out of 2 pi x square psi naught. So by putting omega into 2 omega in above equation, above integral, we get c naught equal to minus infinity to infinity m omega out of pi h cut into 1 out of 4 e raised to the power minus m omega out of 2 pi x square into 2m omega out of pi h cut to 1 out of 4 e raised to the power minus m omega out of 2 pi x square dx. So therefore c naught equal to, so this will is get 2 raised to the power 1 out of 4 and root m omega out of pi h cut minus infinity to infinity e raised to the power 3 omega m out of 2 pi x square dx. So let k is equal to 3 omega m out of 2 pi. So therefore we get c naught equal to 2 into 1 out of 4 and root m omega out of pi h cut minus infinity to infinity e minus kx square dx. So therefore c naught equal to 2 into 1 out of 4 and root m omega out of pi h cut multiply by s. This integral is equal to and root pi by k. So putting the value of k, we get the value of c naught equal to and root 2 and root 2 raised to the power 1 out of 4 to unroot m omega out of pi h cut multiply by unroot pi multiply by unroot 2 pi out of 3m omega. So this will get cancelled, and we can write it as c naught equal to unroot 2 out of 3 into 2 raised to the power 1 out of 4. So the probability is given as c naught square equal to 2 out of 3 unroot. So here we square both sides, then we get 2 out of 3 unroot 2. So this probability